Hello friends, welcome back to my YouTube channel. So in this session we are going to discuss regarding self-induction. So what is this self-induction? So in the previous session we discussed regarding inductance. So what is the inductance and what is its unit and what are its uses like that. So in this session we are going to discuss regarding self-induction. So it is a type of induction. Okay, so there are basically two types of induction: the self induction and mutual induction. So in this session I'm covering only the self induction, so that it is clearly understandable. In the next session I will be covering about mutual induction. So please do watch the entire session, so you will, so that you will not miss any of the important points to understand. So let us quickly start with the session. So what is this self induction? So as we can understand. So what is induction? We already understood in the previous session. So keeping that particular thing in mind, so we'll try to understand now self induction. So if you are still having doubt like what is induction and anything, you can please watch to my previous session, so that it will be more clear in that from that particular session. So now the idea to understand self induction, we will try to immediately proceed. So self induction, so self means from itself, like that, I mean, it is from its own, we can say. So that is the meaning of basic idea of self, meaning of self. So this self generated, I mean it's generated by its own circuitry, is called as self. Here means it's a circuit basically. So in, with respect to electronics or electrical point of view, self is nothing but a self circuitry. Okay, so of self circuit we can say. So self induction means the induction generated or created by its own circuitry. Okay, so this is the basic idea of what self induction. So in an electrical circuit, we'll try to understand in detail of what is the self induction now. So even though we have a basic idea as of now, so in an electrical circuit, when the EMF is induced in the same circuit in which the current is changing, this effect is called as self-induction. So that means the EMF means electromotive force. So if more details are required, you can refer to my previous sessions, or even in detail I'm covering the EMF related session. So this EMF is nothing but, as of now, it's a electromotive force which is responsible for driving the electric current, I can say. So that is the overall meaning of EMF. So in an electrical circuit, when the EMF is induced, means EMF is created or it is done. So EMF is induced in the same circuit in which the current is changing. This effect is called as self-induction. Means whenever EMF is induced in circuit in the and whenever the current is changing, this effect is happening in the same circuitry. That means current is changing with respect to EMF induced in the same circuitry. That is nothing but the self induction. So it is denoted by capital L. So commonly called back EMF, because this self induction, it is called as back EMF because it is generated by its own, or it is the induction is created or generated or happened because of its own circuitry. So as its polarity in the opposite direction to the applied voltage. So this is why this is called is, another reason is as its polarity is in the opposite direction to the applied voltage. We are applying voltage. See, as you can refer to this circuitry here. I hope it's clear. So here it is, we am applying the voltage here. So with respect to that, current I1 is flowing in, a resistance is R1, and this is very important thing which is L1. So as for this point of context, you can just I mean skip this particular circuitry. We are only dealing with the self induction. So in the mutual induction, we have to consider both the circuitry. So for time being, you just ignore this particular second circuitry, which I am pointing it now. So you only consider this particular I1 current, which is flowing now. So L1 induction. So only one thing you can please consider for self induction. So if we want to define mutual induction, then we can define with respect to two circuitries in which I1 current is flowing and I2 current is also flowing. So because of this, the conduction. So that I will be covering anyhow in the later session. But you please try to only consider this one circuitry. The rest circuitry, you just try to ignore it. Okay, with that point in mind, so we'll just proceed. So commonly called back EMF, as its polarity. This polarity is whatever is there is opposite to the direction of the applied voltage. Means, sorry, the polarity of this induction. Okay, so this is opposite to the direction of the applied voltage. Whatever I'm applying, positive, negative, so this is opposite. The induction is generated in the opposite manner. So that is why, because of this reason, it is called as back EMF. Okay, it is reverse of whatever is applied. That's why it is back. So special case of mutual inductance, as it is produced within a single isolated circuit, hence self-inductance is also simply called as inductance. So last actually I have covered inductance, so that particular we can treat it as a self-inductance also. So why I am covering this as an additional session is because in order to get a clear idea about self-induction. So last is also an induction inductance, I mean the session, but the self part is more highlighted here in this particular session. So that is why I'm having a separate conducting separate session on this. So a special case of mutual inductance, this self inductance is nothing but special case of mutual inductance, as it is produced within a single isolated. So as I already told, only to consider this part of circuitry and ignore the second half, I mean the L2 circuitry. Okay, so only circuit 1 has to be considered. So because of this, it is also simply called as inductance or self inductance, both are same. So this mutual induction, whatever I am telling, this will be covered in the next session, immediate session. I will try to cover the mutual inductance topic. So please do subscribe to my YouTube channel and press the bell icon to get the latest updates and notifications. So yeah, have a nice day. Okay, thank you, bye.